Hello again, my beauties. Our next set of notes are on segment relationships in circles. We are looking at the segments of chords theorem, which tells us if we have two chords that intersect each other in a circle, then the parts of each chord are proportional to each other. So we end up with A times B equals C times D. So looking at our first example A, we have this chord right here with the X and the 14, and then we have the second chord with the 12 and the 21. So we get 14 times X equals 12 times 21. 12 times 21 is 252. 252 divided by 14 is 18. So example B, very similar. We have 9 times X equals 6 times 6. So we get 9X equals 36. Divide by 9, and we have X equals 4. C, a little bit more complex because we have an X minus 3 in here. So looking at the first chord with the 6 and the X minus 3, and the second chord is the 4 with the X. So I get 4 times X equals 6 times X minus 3. I went ahead and distributed the 6. Then I subtracted 6X from both sides to get negative 2X equals negative 18. Divide by negative 2, and we have X equals 9. So last one, we have this chord right here, which has the 18X and the 10X, and then we have the second chord, which has the 9 and the 20. So 18X times 10X equals 9 times 20. This gives me 180X squared, and then this side gives me equals 180. Divide both sides by 180, and I get X squared equals 1. Take the square root of both sides, and I get X equals 1. Normally when we do the square root, it would be plus or minus, but if we plug in a negative, we would have a negative length. You can't have a negative length, so